Hello boys and girls, and welcome to the first lesson from Chapter 5. Chapter 5 is expressions, and we're going to start with Lesson 1 on algebraic expressions. Whenever we talk about algebraic, we are talking about numbers that are being represented by a letter. This lesson is found on page 349. So as I was just saying, a variable, let's get familiar with the word. A variable is a symbol, often a letter, that represents an unknown quantity. Okay, so we might not know. So for example, you can have apples plus pears. That would be A plus P. We don't know how many apples or pears, but we do know that we have to add them. An algebraic expression, such as n plus 2, is an expression that contains variables, numbers, and at least one operation. The 2 here is a constant. It's given to us. Right? We know that it's 2 no matter where and when the time takes place. It's always 2. N is not a constant. N is a variable, meaning it can change. Okay? Variable means it can vary. So N can change. And it's whatever amount from day to day it wants to be. Right? Or it will be assigned a different amount depending on the situation. So let me take this opportunity to give you an example of how n can change. For example, in gym class, we have the number of students plus 2 teachers, right? The teachers are always going to be the same, the number of teachers, myself and the teacher that comes to help, right? So 2 teachers. But the number of students will change depending on the level. If it's the intermediate class, it will be 34 students. If it's the senior class, it will be 18 students. So the number of people in the room will change depending on the class. So that's why n will change. But 2 will always remain the same. It's the constant, it's the teachers. Always 2 teachers. Write each of the following phrases in the correct section of the Venn diagram. Contains an operation, has variables and numbers, has only numbers. Okay. So a numerical expression has only numbers. But an algebraic expression has variables and numbers, as you can see right here. And both, in the middle, this is what they both have in common, they both contain an operation. They can both contain an operation, for example, adding, subtracting, multiplication, division, and so on. So in short, an algebraic expression is similar to a numerical expression because it contains an operation. It just has one value that changes depending on the context. Now here's a little tool that will come very handy to us. The expression f minus 32 times 5/9 can be used to convert the temperature from Fahrenheit to Celsius. This is very useful for us because if we travel to the US, they use Fahrenheit in the US, while the rest of the world uses Celsius. In this algebraic expression, the variable f represents, oh, that's not a very nice f, sorry, represents the temperature in degrees Fahrenheit. So again, this will change. It will vary depending on the temperature of Fahrenheit. All you have to always do is subtract 32 from it and then multiply it by 5/9. Let's get familiar with some of these algebraic expressions that we see here. These are called terms, okay? When we have here, the branch of mathematical that involves expressions with variables is called algebra. So we're doing algebra. In algebra, the multiplication sign is often omitted. For example, 6d, whenever you have a coefficient or a number and a variable next to each other, the operation is multiplication. So 6 times d. 9st is 9 times s times t. mn is n times n. And a to the power of 3 is a times a times a. The numerical factor of a multiplication expression that contains a variable is called a coefficient. So the numerical factor, this is saying the number part. So 6, 9, those are the coefficient. Obviously not the 3 because that's an exponent. So 6 is the coefficient of 6 d, 6 times d. Expressions like y over 2 can be rewritten as y divided by 2. You see, y divided by 2. Numerator divided by the denominator. Or y times a half. Remember, when you divide something by 2, it's the same as multiplying it times a half. And I'll explain why, because if you have y divided by 2, it means you have to put 2 over 1, which is the same thing as saying y, and then you find the multiplicative inverse of 2 over 1, which is y times 1 over 2, right? So y times a half, as you see there. For the following 3 examples, you will see how we replace the variable in each equation. And the value of the variable has been given to us. You can see it right here, right there, okay, and right there. All we have to simply do is replace them. Okay, so let's go ahead. And you can see here that you have 2 times n plus 3. Remember to follow order of operation where we do our brackets first. Okay, we replace the variable first, the n, replace it with the -4 as we're told here to do. And then we solve, so -4 plus 3 is -1, and then 2 times -1 is -2. We do the same here. We have 8w minus 2v. W is W is 5 and v is 3. So we replace them, so we have 8 times 5 minus 2 times 3. Multiplication comes before subtraction, so we have to multiply first. We have 40, 8 times 5 is 40, and 2 times 3 is 6, and 40 minus 6 is 34. So you can see the following order of operation is very important. 4y to the exponent of 3 plus 2, if y is 3. So let's replace y with 3. And it looks like we have 3 times 3 times 3. 3 times 3 times 3 is 27. Times 4 plus 2 is 110. They could have included one more step here where they write 4 times 27 is 108 plus 2. Right? Plus 2. Okay, let's try solving these next 6 questions. This would be a good time for you to pause the video and try these all on your own. So please pause, do them, and check your answer afterwards. So pause the video now. For the first question, we have c minus 3. As you can see here, c minus 3. c is 8. It's a value of 8, so we're going to go ahead and replace the variable c with 8 minus 3 equals 5. For b, we have 15 minus c. We replace the variable with 8 because c is 8. And our answer is 7. For c, we have 3 times c plus d. Let's replace the variables. So now we have 3 times 8 plus -5. 8 plus -5 is 3. Times 3 is 9. 9 is our answer. Now we have 2c minus 4d. Let's replace the variables. So now we have 2 times 8 and 4 minus 5. So 4 times -5. So this becomes 16, and 4 times -5 becomes -20, so it's minus minus, which becomes plus. So it's 16 plus 20, and it becomes 36. D minus c squared, let's replace the variables. D is -5 and c is 8. So don't forget that the values are given already. So there's d -5 and minus c, which is 8. So we have again 8 times 8, because it's 8 to the power 2, is 8 times 8. So we have -5 minus 64. It's going to be a bigger negative number because we're taking away more. It is -69. And now we have 2d squared plus 5d. And when you replace the variables, it becomes 2 times -5 squared plus 5 times -5. So this becomes negative 5 times negative 5 is positive 25 times 2 plus negative 25, because 5 times negative 5 is negative 25. So we have to now continue with order of operation. Now we multiply and then we add. So let's multiply. 2 times 25 is 50 plus negative 25, or just 50 minus 25, is 25. I hope you were able to check all your answers and then you got most of them correct, if not all correct. Let's look at a real world example where we use a variable to identify a number that changes. Athletic trainers use the formula 3 times 220 minus A divided by 5, where A is a person's age, to find their minimum training heart rate. So when you want to find their minimum training heart rate, you simply input the person's age into this formula and you can find their minimum training heart rate. Find Latrina's minimum training heart rate if she is 15 years old. So as you can see, we take the formula, we replace the variable, we solve by using order of operations, so BEDMAS or PEMDAS. First do the parentheses, then we multiply and then divide, and we get 123. So it's 123 beats per minute. Okay, why don't you go ahead and try out question G. So read it and pause the video and then check my answer. Okay, pause now. To find the area of a triangle, use the formula base times height divided by 2, where B is the base and H is the height. What is the area in square inches of a triangle with the height of 6 inches and a base of 8 inches? You see how these have to be variables because the triangles will always change in sizes. So depending on the size of the triangle, that is what we input into the formula for the variables. So I've gone ahead and replaced the base with 6 and the height with 8, all over 2. So 6 times 8 is 48 divided by 2, and that equals 24. Therefore, the area of the triangle is 24 square inches. We also need to learn how to translate a real-world scenario into an algebraic expression. For example, to translate a verbal phrase, or a verbal phrase is a real-world scenario, into an algebraic expression, the first step is to define the variable. What is the number that will be changing, that will be varying? When you define a variable, you choose a variable to represent an unknown quantity, a quantity that will differ each time. So Marissa wants to buy a DVD player that costs $150. She already saved $25 and plans to save an additional $10 per week. Write an expression that represents the total amount of money Marissa has saved after any number of weeks. So the number of weeks will be our variable. So 10 times W, and then the W can be replaced with the number of weeks. So as we see here, the wording is savings of $25 plus $10 each week. We let W represent the number of weeks. So we have our $25 plus $10 for each week, per week. And this is how we would write it, 25 plus 10W. There you go. And that's it for today. See you in class, everyone.